Good morning friends, I welcome you all at your favorite YouTube channel VIGYAN VIHAN. This is our problem solution series of General Aptitude Part A of UGC CSIR Net. In this episode we will solve problem number 16 to 20 of Mathematical Sciences paper of June 2017. The General Aptitude part plays a vital role in UGC CSIR Net. It would be helpful for you to achieve a higher score and higher rank. So all the best for exam. Let's start the solution. Friends, here is the first problem of this episode, problem number 16. If NET 14 and NET 15 are 5-digit numbers such that their sum is equal to 1,57,229, then n plus e plus t would be option 1 15, option 2 21, option 3 25, option 4 72. Here is our first problem, problem number 16. If NET 14 and NET 15 are 5-digit numbers, the first number is NET 14 and second number is NET 15. The sum of these two numbers is 1,57,229. Use the notation for NET. Multiply this number with 100 plus 14, and for NET 15 you can write here NET 100 plus 15. The sum of these two numbers would be NET 200 plus 29. Now after equating this expression with the given value of the sum, this expression is equal to 1,57,229. So NET 200 would be equal to 1,57,200. Now the NET value can be calculated by solving this equation. 1,57,200, divide it by 200. You will get the value 786. That is 786. That is the value of NET. These numbers are like 786, then 14, and the second number is 786, 15. The question is asking the value of n plus e plus t would be, the n value is here 7, e value is here 8, t value is 6. So n plus e plus t value can be calculated by putting the values of these three digits, 7 plus 8 plus 6. So 7 plus 8 plus 6 would be equal to 21. So correct answer of this problem is 21. That is option 2. 72. Friends, here is problem number 17. A cylindrical cake is to be cut into 16 equal pieces. What is the minimum number of cuts required to do so? Option 1 9, option 2 3, option 3 8, option 4 5. Friends, here is the next problem, problem number 17. In this problem, question is asking the number of minimum cuts required to cut a cylindrical cake into 16 equal pieces. Imagine the cake is like this, which is in shape of a cylinder. Then for minimum number of cuts required to cut it into 16 equal pieces, we will have to cut it vertically 4 equal parts. So the number of required cuts would be 1 2 3, 1 2 3. Now this cake is divided into 4 equal parts vertically. Now we will divide it from the above direction vertically again, so that the cake will be divided into 2 equal parts by this single cut. So this is the 4th cut, and after that by dividing it perpendicularly from the fourth cut, this is fifth cut. In fourth and fifth cut, these circular part will be divided like one single cut that will cut into two semicircles, and the fifth cut will divide it into four equal parts. These are quarters of the circle. So now this cake is completely divided into 16 equal parts. So the correct answer of this problem is minimum number of cuts required is 5. So that is option 4 here, 5. Or 5. Problem number 18. The diagram shows a cubic block of marble that is 1 by 1 by 1 meter cube having a planar fracture. What is the maximum number of slabs sized 20 by 20 by 5 centimeter cube that can be cut from this block avoiding the fracture? Option 1 200, option 2 300, option 3 400, option 4 500. Friends, here is the next problem, problem number 18. In this problem, there is a cubical block which is divided into two equal parts by a planar fracture such that this plane divides the front face into two equal right-angled triangles. We will have to find out the maximum number of slabs sized 20 by 20 by 5 centimeter cube that can be cut from this block avoiding the fracture. So, the first requirement is to avoid the fracture and cut these blocks into smaller slabs. Now, we will divide first the linear part. We consider this axis as y-axis, this axis as x-axis, this perpendicular axis with respect to the plane of this green board as z-axis. First we divide the length of the cubical box which is parallel to z-axis into length of 5 centimeter. So we know here that each dimension of this cubical block is 1 meter by 1 meter by 1 meter. So when dividing along z-axis, the number of slabs which can be cut parallel to the z-axis with the length 5 centimeter along z-axis would be 1 meter. Divide it by 5 centimeter. The 1 meter quantity is equal to 100 centimeter. So it will give you the value 20. Now this is the first part of our solution. If I put this prism like this, in that condition the length here which was along z-axis will have the number of slabs along z-axis equals to 20. Now this triangular part here will be divided into square shape of 20 by 20 centimeter squares avoiding the fracture. Like this is a triangular shape which have the base length 1 meter, height of the triangle which is also 1 meter here into the square shaped segments of 20 by 20 centimeter square dimensions. The base which have the length 1 meter will be divided into 5 equal parts of 20 centimeter length segments. So here it is the first part, the second part, the third part, the fourth part. Now the perpendicular will also be divided into 5 equal parts. The first part, second part, third part, fourth part. Now we can count the number of squares of 20 by 20 centimeter square area segments. Here it is 1, 2, 3, 4. On the base step it is 4 number of squares avoiding the fracture plane. On the second stage it is 3, 1, 2, 3. On the third stage it is 2. On the fourth or uppermost step it would be 1. The remaining area of this triangle, which are the triangular areas, will not be counted for this purpose. For the remaining other second triangular area, there would be same situation and there also would be same number of squares avoiding the planar fracture region, so you can directly multiply it with 2 to get the total number of squares which can be cut from this front face of the cube. So the total number of squares can be calculated by 4, 3, that is 7 plus 3, that is 10. So it is 20 after multiplying it with 2. Now along z-axis the slabs can be cut into 20 equal parts of 5 cm length, and along the xy plane this planar face can be cut into 20 aerial segments of area 20 by 20 cm squares. So we can directly calculate the maximum number of slabs of this size which can be cut from this cubical block by just multiplying 20 with 20. So you can directly write here 400. Otherwise you can use the formula for the maximum number of slabs of this size which can be cut from this total cubical block by this formula 1 by 1 by 1 meter cube, divide it with 20 by 20 by 5. Now we can write here 1 by 1 meter square, divide it with 20 by 20 centimeter square, and then multiply it with 1 meter upon 5 centimeter. That will give you the value 20 simply. And here also 1 meter square, divide it with 20 by 20 centimeter square. This numerical value you can get from here. This is 20. So for utilization purpose, from the limiting condition you can get the total maximum number of this size slabs will be 400. So the correct answer of this problem is 400. That is option number 3. Problem number 19. This problem is based on a graphical plot for pre-PhD exam score of 10 students and their MSc marks. We will have to find out the true statement out of given 4 statements. Option 1, 2 students have scored better in pre-PhD than their MSc exam. Option 2, all those students who scored 50% in pre-PhD scored more percentage of marks in their MSc exam. Option 3, 2 students scored the same percentage of marks in their pre-PhD and MSc exams. Option 4, the student who scored maximum in MSc is the only student to get maximum in pre-PhD exam. Friends, here is the next problem, problem number 19. This problem is based on the marks of pre-PhD exam versus the marks of MSc exam of some PhD students. From the given information in the chart, we have targeted only the important part of this graph, which consists all the required information we need here, which is given in the problem. We will have to find out a proper conclusion which is certain by the given information from the given 4 options. So first we will make the table of MSc marks for students and their PhD marks. So first we give them some name A, B, C, D, E, F, G, H, I, and then J. So these are the 10 students. So write here the MSc marks, pre-PhD marks for the same students. For student A, for the student A, the MSc percentage is 40. His percentage in pre-PhD exam is 30. For the student B, the MSc marks is 50%. For pre-PhD exam, he scored 30% of marks. So here it is 30. For student C, the percentage marks in MSc exam is 40, and in pre-PhD there is same percentage of marks, so 40 and 40. Student D scored 50% marks in MSc and 40 in pre-PhD exam, so we will write here 50 then 40. For student E, he scored 40% in MSc exam and 50% in pre-PhD exam. For student F, his percentage marks in MSc exam is 60, in pre-PhD it is 50. So here it is 60 then 50. There is lack of space down here, so we will make this table like MSc percentage of marks, pre-PhD percentage of marks, and name of the student, that is A, B, C, D, E, F, G, H, I, J. For MSc exam, we will write the complete information which is derived by us here. For the remaining students, for student G and H, their MSc percentage of marks is 70 and 80. So write here 70 then 80. Both have same percentage of marks in pre-PhD exam, that is 50. For I and J, their percentage of marks in MSc it is 70 then 90. But in pre-PhD both scored the same percentage of marks, that is 70. Now we will read the given 4 options and will try to find out a true statement out of the 4. First, 2 students scored better in pre-PhD than their MSc exam. Let's find out those students who scored better in pre-PhD than their MSc exam. So, one is here who scored better in pre-PhD than his MSc exam, and no such other student found. So, the option 1 may not be the correct statement. Option 2, all those students who scored 50% in pre-PhD. So, let's consider those students who have scored 50% in pre-PhD. These are 4 students, E, F, G, H. These students scored more percentage in their MSc. Let's consider it. Their percentage of marks in MSc, the candidate E has scored lesser percentage of marks in his MSc. So this condition is also violated, so that is also not a true statement. Option 3, 2 students scored same percentage of marks in their pre-PhD and MSc exam. So let's search these students who scored same percentage of marks in their MSc exam and pre-PhD exam. The first student is C. The second student is I. Both scored the same percentage of marks in MSc and their pre-PhD exam. So option 3 is the true statement. That's the correct answer of this problem. Again, we will consider the option 4 to check our final conclusion. Option 4, the students who scored maximum in MSc. The student who scored maximum in MSc, that is J is the only student to get maximum marks in pre-PhD exam, but in pre-PhD exam he scored 70 marks and same marks is also scored by the other student I. So that's also not a true statement. So the correct answer of this problem is option 3. The last problem of this episode, problem number 20. With reference to the right-angled triangle shown, what is the value of sin A cos B plus cos A sin B, where A and B are the angles of a right-angled triangle? Option 1 minus half, option 2 1, option 3 plus half, option 4 minus 1. Friends, here is the last problem of this episode, problem number 20. In this problem, there is a right angle triangle and its angles are A and B as shown in the figure. Question is asking the value of sin A cos B plus cos A sin B. We know it better. The formula sin of A plus B will give you the value sin A cos B plus cos A sin B. If anyhow I can get the value of A plus B, we can definitely find out the value of sin A cos B plus cos A sin B for a right angle triangle. We know it better that for a right angle triangle the sum of the remaining angles would be equal to A plus B, that is 90 degrees, or simply from total of the three angles of a plane triangle, you can easily calculate 90 degree plus A plus B would be equal to 180 degree. Then also you can get A plus B is 90 degree. Now put this value in this formula. You will get the value of this complete expression sin 90 degree. You better know the value of sin 90 degree, that is 1. So the correct answer of this problem is definitely option 2, 1. Friends, you can download the PDF of this paper from the Google Drive link given in the description below. Keep practicing. Wish you all the best for your exam. Thanks for watching this video. If you like this video, please share it with your friends. Please subscribe this channel and don't forget to tap on the bell icon so that you can get notifications. Thank you.